Okay. Previously, we saw the Java nested try block, and nested try block, when you have the try block, and then you have further try block in that try block, or you can have further try block inside another try block. So this is called nested try block. We already have seen. And now we are going to start Java finally block. Uh, Now we have learned what is try block, we have learned what is catch block, and now this is the time for the finally block. Because normally this finally block comes after the catch block. After the catch block. So we normally use this finally block to execute the cleanup code. What is the meaning of this cleanup code? We use this block only to execute cleanup code. What is the meaning of this cleanup code? Normally, the first example is that if you are writing a program and in that program you are handling some files, then definitely you will use some object, and then through object you will use the object of some existing class, and through that object you will open the file, and then you will do something on that file, and at the end you want to close that file. The closing of that file is necessary because otherwise the garbage will remain in the memory. So that's why that closing of file, that step is called the cleanup code. A cleanup code in this example. Similarly, when you have written some program, or when you are doing something with your program, uh, and you have many objects and variables introduced in that program, and if your program is running and now your program is at the end of its execution, if you will not close different objects that you used in that program, then what will happen? That after the end of your program, those objects or some variables will remain in the memory and they will take the memory. So that is called garbage. That is called garbage in programming languages. So then you have to close those variables or objects. So that is again a normal example of cleanup code. So that's why this Java finally block that we have in Java, we used this block for the cleanup of our code, such as closing the connection. If we are using database in our program, then there is normally a connection that you have to build with your database in your program. That connection would be a name of some object. So then you again have to close that connection before the end of your, if your program is running. So before termination of your program, you have to close that connection. So that is also an example of cleanup code. Closing a file is also an example of cleanup code. So Java, what is the use of Java finally block? The use of finally block is that in this block we can introduce the cleanup code. Okay, and then after that, if you have the finally block in your program, then either exception is generating in your program, are handled in your program, this does not matter. This does not matter. So in your program, if you have the finally block at the end, then either exception is occurring or not, this does not matter. Finally block will execute always when its turn will come. When its turn will come. So, and where we can introduce this try block? After the try catch block. After the try catch block, you can introduce this finally block. And this is a simple data flow diagram of the finally block. And suppose that this is Walaikum Assalam. And suppose that this is the source code of your program is going on. Suppose, and in your program, if you have a code, and in your program, suppose add some statements, if exception is occurred, it can be yes, it can be no, exception can be occurred or no. Add some statement, for example, 50 divided by 0, this is a statement which is generating an exception. So suppose add some statement, we have a condition that exception is occurring or not. If exception is not occurring, then the control of your program will go directly to that finally block, and then it will execute that finally block. And further thing, if exception is occurring, if exception is generating in your program, yes, if it is generating, then what? If exception generates in your program, what is the next step? You must have to handle that exception. That is the next step. If in our program exception will generate at some statement, then what is the next step? The control will go to the catch block for handling of the exception. So that's why if exception is occurring, then we have to handle that exception. We have to handle that exception. And here we have the catch, we should have the catch block that will handle the exception. If you handle the exception, yes, then after handling that, after executing the catch block, the control will again go to the finally block to execute the statements in it. And if you don't have any catch block, if you don't handle the exception, then if it is not, you are not handling the exception, then the control will transfer to the finally block again to execute statements which are in that finally block. So finally block is what? Finally block is executing in all the conditions. In all the conditions, finally block is executing. Either exception is occurring in your program or not. If occurring, then okay, it will be handled first, and then the control will go to that finally block. If not, then the control will directly go to that finally block to execute the statements which are there. This is just a note that if you don't handle the exception before terminating the program, your program is going to terminate, and if you don't handle the exception is still, your program is generating exception, but you don't have the proper catch block for your exception to handle that exception, and your program is now going to terminate. Who will terminate your program? The JVM. The JVM will take the control of your program, and then it will terminate with some abnormal message. But before that, if you have the finally block there, then this block will be executed before the termination of your program. So this point is again saying that the finally block will always execute if you have that block in your program, but it will be executed at the last step, at the end, at the last step. Okay, now we have some examples. We have case one on the left hand side, and that case is about when an exception is not occurring. So here on the left hand side, we will see this program, and here exception is not occurring in this program. And then what will happen with the finally block, we will see. So this is just a class test finally block starting and ending here. And then we have the main method in that class starting and maybe ending here. And then we have the try block, and try block is this one. And then we have the catch block for this try block, okay. And then we have the finally block starting and ending here. And this statement is independent. It is not with any block here, okay. It is independent, okay. Now we have seen the structure of this program. So when you will run this program, it will directly go to this main method and it will execute this main method. And here in this main method, we have the try block first. So we will go into this try block and we will start executing these statements. And first statement is saying int data 25/5. So 25/5, you have the answer 5. You have the answer 5. So then what? Okay, there is no exception. That is perfect. System.out.println and that data. What is the value in that data? 5. That 5 will be printed, and which you are seeing here in the output here, okay? And then, okay, there is no exception. So, okay, we will come out of this block now because now it is ended. We now come out of this block now normally, and the control will come here. And after that control, what is the block? Catch. Catch is normally connected with some try block. So this is the try block. So now this catch will not execute because we don't have any exception here in this try block. So then what? The control will go directly after this catch block here. The control of the program. It will go there and it will search for the next statement. Next is finally block. Okay, it will execute now this finally block. It will go inside and it will execute the statement one by one. We have only one statement, so that will be executed. And finally block is always executed. This message will be printed on the screen as you are seeing here. And after, okay, there is no statement next. So then what? We will come out of this finally block and the control will be shifted here. And it will search for the next statement. This is the next statement. And this rest of the code that will be printed on the screen, which you can see here, at the end. So here in this program, we don't have any exception. But still the finally block is executing because we said that finally block will execute always. Either you have the exception in your program or not. At the end of your program. Now case 2 on the right hand side, what that program is saying. Here, when an exception occurs, but not handled by the catch block. So in this block, it is an instruction that some exception will occur, but it will not handled by the catch block. Let's see what will happen. So here we have this class, public class test finally block, starting from here, ending here. And similarly, the main method starting from here, ending here. And then we have the try block, starting and ending. And then we have the catch block for this try block. Then we have the finally block, and this statement is independent. Again, this has the same structure as we have here. So now when we will run this program, the control will go to this main method. it will start executing these statements one by one. So this is one statement. Now we will go into this try block and then system.out.println inside the block, So this will be printed first. And after that, what is the next statement? This one, 25 divided by 0. Okay, that is an exception is occurring here. Divide by 0. Arithmetic exception. Arithmetic exception is occurring here. And then what? Where the exception is occurring, we will stop at that point and we will come out of this try block. The control will come out of this try block here and it will search next for the catch of this exception. And what is the exception? Arithmetic exception. So we will go now into this catch block. We will search. Is it arithmetic exception? No, it is not. Type is not matching with the exception which is occurring here. So when type is not matching, then this catch will not execute. And then we will come out of this try block and we will be here. And we will be here. And then what? We have the finally block. So finally block is what? It will execute always. Either you have the exception or not. So we have exception occurring, not handled. Okay, the program will terminate abnormally. This is one thing we have in our mind. But finally block will execute before the abnormal termination. This is the note mentioned here. Even if your program is terminating abnormally, but before the abnormal termination of your program, the finally block will always execute. So now the control will go into this finally block. That finally block system.out.println, this message will be printed. This message will be printed. And after that, we have exception here. Still, we have exception here, which is not handled. And we don't have any, it will, so your program will try to search for some catch block, but we don't have any catch block. So here we have this last statement, but this last statement will not execute because the exception is still in the memory, is still in the RAM, searching for the catch block to handle that exception. So then what? After executing the finally block, now your program will be terminated here abnormally. And now you will see the next messages here, exception in thread main is the method. And you have the exception there, java.lang arithmetic exception. What type of exception? Arithmetic. What is that? Divided by 0, this is exception message. And add test finally block main, test finally block. This is normally the line number. So this is line number 9. And then your program will terminate. So this message which you are seeing in the output screen, this is by the JVM. This is by the JVM and not by any statement in your program. This statement is causing that. This statement is causing that exception, but that message is displayed on the screen by the JVM, Java Virtual Machine. And then your program will terminate it abnormally. Okay, abnormally. Your program will not be terminated normally. It will be terminated abnormally. And the control will be shifted to JVM. So here in this case, we have something wrong with our program. We don't have the proper catch here. That's why our program will not execute properly. Case 3, left-hand side, we have case 3. When an exception occurs and is handled by the catch block. So now maybe in this program, exception is occurring and we are also handling that exception through some proper catch block. Okay, so this is the public class test finally block, starting and ending. Then we have the main method starting and ending. We have the try block. Then we have the catch block. finally block, and then this statement is independent. So now when we will run this program, we will go into this try block here, and first system.out.println, and inside the try block, so this message will be printed as you are seeing it here. And then int data 25 over 0. So you are dividing some number with 0. So exception is occurring. What is that one? Arithmetic exception. Divide by 0. So exception is occurring. So stop at that statement and come out of this and come out of this and search for the catch block. What is that catch block? We have the exception here, arithmetic. So here we have the catch and the arithmetic exception. So type is matching now. This exception which is occurring here is now matching with this catch block. When it is matched, then that exception which is throwing on this statement, it will be copied into this object E. And then what? System.out.println exception handled. So this message will be printed on the screen. And after that, what is the next statement? This one, system.out.println E. Whatever you have in the E, that will be printed on the screen. And what is normally we have in that E? Stack trace, print stack trace, and with the exception message, exception. So java.lang.arithmetic exception or divide by 0. So that will be printed by this E. And now it is the end of the catch block. So okay, the control will come where? The control will come here to the next block. What is that block? Finally. Okay, executed. And here, finally block is always executed. So we have the exception here before, which is now handled here. And after that, we have the finally block. Okay, finally block is always executed. So this statement will be printed on the screen, which you can see here. Okay, we don't have any further statements in this block. So control will be shifted here to the next statement. And that is system.out.println rest of the code. That will be printed, which you can see here on the output screen. So now this is a proper program in which everything is handled properly. And the finally block is also executing at its turn. So this is some kind of a rule, syntactical rule, nothing else. And this is saying that for each try block, if you have the try block in your program, then there can be 0 or more catch blocks for that try block. Then there would be 0 or more catch blocks for that try block, but only one finally block. So why finally block in your program, normally it has only one occurrence. You cannot write it 2 times or 3 times or 4 times. No, only one time at the end of your program, because we use this finally block for the cleanup code. And I already explained what is cleanup code. Here we are not writing the cleanup code. We are writing just general statements according to this program. But anyhow, what is the main purpose of the finally block? Cleanup code, and which I explained in the beginning. Now, we have next topic, Java throw keyword. We have seen now the try block, we have seen the catch blocks and their different cases. We have seen the finally block and their different cases. We have seen the nested try block and its different cases. And now we are going to see the throw keyword. So the one thing is that this keyword throw, we use this keyword when we want to throw an exception by ourselves. Being a programmer, if you want to throw an exception by yourself, not by any statement of your program, you want to throw an exception in your program, being a program, then you can use this keyword. Then you can use this keyword throw, and you can throw any exception in any program. So you can also build a program in which you will throw some exception, and that program will be automatically executed. And then you can copy that program and give to your friend and say him, okay, look this file. And when he will look that file into his computer, because that was automatically executed, so that exception will be occurred. And then he will feel that maybe you can give a message, now everything is going to be deleted, etc., etc. And then maybe he will be worried, what is happening there? What you have given to me? So you can do the tricks like that with this keyword. So throw is a keyword through which you can throw a, an exception by yourself in your program. This is one thing, the major thing to understand what it is. So we will use this keyword to throw an exception explicitly. Explicitly means when you want to throw exception manually in your program. Explicitly means manually. Implicitly means when something will be or will happen automatically, that is implicit. And when you will do that thing manually, that is explicit. So how we can use this throw keyword? We have to write or specify the exception object. If you want to throw an exception, then we know that that exception must be related to some class. For example, divide by zero exception is related to arithmetic exception. And there are also some other exceptions. File not found exception, that is the name of the class. Input output exception, that is the name of the class. Array index out of bound, that is the name of the class. So all are the names of the classes. And if you want to throw an exception, that exception must be related to some class. And how you can relate with that class? Through object. So when you will throw an exception, actually you will throw the object of that exception class. You will throw what? You will throw object of that exception class. So if you want to throw some exception, then you must have to specify that object of that exception. That object of that exception. You must have to specify. Specify means you must have to mention, you must have to write in your program that which exception object you are going to throw. And when you normally throw an exception object, there is also an option of sending your own message, with that. For example, previously here, java.lang arithmetic exception divide by zero. So this is the message which is already built in arithmetic exception class. You can change these kinds of messages. You can change. So you can change these kinds of messages also when you are throwing an exception object. So exception, every exception has some message with it. that provides the description of that error, that exception. And you know that we have different exceptions. Some exceptions are related to arithmetic, some exceptions are related to inputs, some exceptions related to servers. These are not the only ones that you have seen in the beginning of this lecture. There are many others related to your networks, which is not displayed here in the beginning diagram of this lecture. So we can throw these exceptions. And what are the different types of exception? Checked and unchecked. This is what we saw in the beginning of this lecture. There are two categories of exceptions, checked and unchecked. Checked will be checked at compile time, unchecked will be checked at runtime. So we can throw both of these types of exceptions using this throw keyword. But we mainly use this throw keyword to throw only custom exception. All the exceptions that we used up to now, arithmetic, input, file not found, array index, whatever it is, all these exceptions are already defined for our use. But what is custom exception? Custom exception is something, an exception class that you will define as a programmer in your program, and then you will use it. That is called custom exception. So mainly we use this throw keyword for those custom exceptions. What is custom exception? We will build our own class of exception, and then we will have our own messages in that class, not divide by zero. Maybe we will have our own messages. And when we will have that custom exception, then we can throw that custom exception along with our own messages. Let's have a look over the syntax of this throw keyword. So how you can use that, how you can write that statement. So now this throw is the keyword. This is what you have to write like that. And then after that, throw keyword can throw the object of an exception class. So that's why then after that you have another keyword new. New keyword you normally use to create objects. For example, if the class name is test, then you write normally test obj is equal to new test parenthesis semicolon. So on the right hand side you used the keyword new to call the default constructor, not only call, but here in my example which I have given you regarding this test, here I am calling constructor. So anyhow, this keyword new we use to create memory. And here throw keyword, and then again we have the reserved word new, and then here you can write the name of the exception class, whatever it is. If it is arithmetic, you can write the arithmetic name. If it is array index out of bound, you can write that array index out of bound, file not found, whatever the exception name of the class is, you can write it here. And then parentheses, and within the parentheses you can write your message, your own message. You can write whatever message you want. You can write your own name here. Or if you are introducing some kind of error message, then you can write that error message here. So this is the syntax. Now, for example, here, this is a general syntax. We are not writing some specific exception class name here. This is general syntax, which is just giving an idea that how you can write things. But here we are throwing something, actually. So this is the throw keyword, then there is a word new. Input output exception. This is the name of an exception class. Input output exception, proper class. This is a proper exception class available under the throwable class, under the exception class in the diagram which you have in the beginning of this lecture. So IO exception, this is now the proper name of an exception class. And then parentheses, and then you are giving your own message that sorry, device error. Okay. So this is the use. Now this statement will do what? Now this statement, wherever this statement is in your program, this statement will throw an IO exception with this message. With this message.
So, the exception in the server class, not different IO exception.
Sorry again. This exception which I mentioned here, not different with this one?
No, yes, different from underscore. Different or not different? Underscore.
This underscore?
Under code, not underscore.
Undercode.
IO exception.
Yeah, this IO exception is the name of an exception class. So then what? What is your question now?
So you have different invite underscore from exception before the printed from the error message. Another code said
this is different from arithmetic exception. For example, here you want, for example, here divided by 0. This is what you want. After the underscore, what is your question actually?
Underscore is this.
Here we don't have any underscore. Where is underscore?
No problem.
Okay, you are saying that if you will introduce underscore between IO and exception?
Yes.
No, it is a problem. Okay, you have, this is the name of the exception class. You have to use that name as it is. If we will go in the beginning, this is the IO exception class. You have to use that name. You cannot introduce underscore or comma between their names, okay? You have to use these names as written here. So, using this throw keyword, you can use any exception class here, which is available under the throwable class or is the subclass of that throwable. It's mean the same thing. I have shown you the diagram just which is available in the beginning of this lecture. So you have at the top throwable class, and then you have the exception on the left side, error on the right side. So what this statement is saying, that you can use this throw keyword to throw any exception, which is available under this throwable class, which is available under that throwable class. What it means this one. This is the throwable class. So you can throw any exception which is available under this throwable class, all these classes, you can throw these exception classes by using that keyword throw. This is what we are trying to say. This is what we are trying to say. Now we are going to see how we can use this keyword. An example one is about throwing unchecked and checked exceptions. And you know that from that diagram, the beginning three are the checked exceptions and the remaining are the unchecked exceptions. So in this example now, is it visible? In this example, we will have some method. The name of the method is validate. The name of that method is validate. That method will take some integer value as a parameter. And if that value would be some number, that value would represent some age. If the value of the age would be less than 18, then we are throwing the arithmetic exception in our code. Otherwise, not. Let's see. So we have the class test throw starting from here and ending here. And then in that class, we have this validate method starting from here. And this is if, else, ending here. So this is the method validate, and this is his area. This is its area. After that, we have the main method starting from here, ending here. Now this is our program. When you will run it, it will search for the main method. It will find the main method here, and then it will execute that method. Whatever in it, one by one. So it will go inside, and this is the first statement, validate and passing some value 13. Okay. So we will call this validate method, and we will copy this 13 value into it. So that 13 will be copied into this age. Now 13 less than 18, condition true. When condition true, so this is the starting block, ending block of that if. Condition is now becoming true, so we will come inside. And this is the statement now. This is just a comment. So this is the statement now, and here it is written throw new arithmetic exception, and this is the message. So here we are doing what? We are throwing arithmetic exception with this message and not divide by 0. Okay, now message is changed. Okay, so we are throwing arithmetic exception, and previously we have seen what is the message for arithmetic? Divide by 0. But here we are giving our own message. Person is not eligible to vote. That message will be copied here. That message will be passed as a parameter to the constructor of this arithmetic exception. And this arithmetic exception is the child class of what? I want to just check. This arithmetic exception is the child class of which class? Exception. Huh? Exception. Exception class. Who is the parent of that arithmetic exception? Exception class. So this message via the constructor of this child class, this message will be further transferred to the constructor of the exception class, and then it will be updated there. Anyhow, leave it. Take it simply as that this is now, we are here through this keyword throw, we are throwing this arithmetic exception, and with our own message. This is now our message for that exception, not divide by 0. Okay, and this new keyword will do what? Basically, this is what you are doing. We are calling the constructor with, and we are passing that value into it. But leave it. Leave that understanding. That is exact understanding, okay? What is happening here? What is happening here? Here we are calling a constructor of arithmetic exception class with this value being passed as an argument. This is the exact understanding, but leave it. What is the abstract understanding? So this keyword throw is just throwing that arithmetic exception, and this would be the message of that exception now. And the keyword new is also there. Anyhow, so now when this statement will execute, exception will be thrown here at this statement. When exception will be thrown, you have to stop there. And you have to come out of that try block. But we don't have any try block here. Okay? We don't have any try block here. This is simply a method. This is simply a method. So when you have an exception at some statement, stop at that point and come out from that block with that exception message. So I can come out of this validate method here, but no, I will try the try block. Where is try block? We don't have any try block here. So then what? Your program will terminate. Your program will terminate. Your program will terminate abnormally. So when you don't have that try block, it means you don't have the catch block. Even you have written the catch block, nothing will happen because you don't have the try block. First try block is needed. And if you have that exception, then we will come out of that exception. We will come out of that try block, and then we will search for the catch block. And if you have that proper catch block, then the exception will be handled there. And after that, we will see either the program is going normally or abnormally. But here, we don't have that try block, so our program will terminate abnormally. And when our program will terminate, the control will go to the JVM. And then JVM will take that exception which was thrown in your program. This exception was thrown. And who will display this exception? JVM now, not your program. Your JVM will take the control of your program, and it will take what is the exception message you have here. That's why this message that you are seeing here, exception in thread main, this is the main method. In the main method, you are calling this validate, which you are executing it here. Exception in thread main java.lang. And what is that exception? Arithmetic exception. Okay, arithmetic exception. And then here, not divided by 0. Rather, we have this message, which you have given here. Person is not eligible to vote. That message is displayed by this whole thing is displayed by the JVM, not by your program. And then after that, it is showing the line numbers where this exception is occurring. At test throw, this is the name of the class, test throw. At test throw 1, validate is the method, and then test throw 1.java, line number 8. So this 1, 2, 3, 4, whatever it is. So probably this line number 8 is just giving you an idea that here, this line and this method call. What is its line number? At test throw 1.main test throw.java, line number 18. So this whole story is displayed by the JVM, not by your program. And your program is terminating abnormally. Clear? Normally up. What you want to say? I am saying that now here in this case, our program is not executing or finishing or completing itself normally? No, it is not. This program is not executing normally. Rather, because we don't have the try block and we have the exception here, and that exception is not handled, so JVM will take the control. It will take that exception along with its message, and then it will display all those messages. And you will not get some useful from your program now because you have some issue with your program. And now, and here arithmetic exception, and here arithmetic exception is a unchecked exception, runtime exception. This is the case of unchecked exception. Now we will see for some checked exception on the right hand side. Let's see. Here we are importing something java.io.star, which means that whatever you have in the IO directory, input output directory, which is available in Java directory, whatever you have. Allah, Allah. Better or not? Yes. So here java.io.star. So this is what is the meaning of this one? It is the meaning that we are in the folder Java, and then we have another folder IO in it, and then whatever files you have in that IO, include all those files, import all those files in this program. So all files are now attached with this program, are imported. And then we have the class, name of class is test throw 2, starting from here, then maybe ending here. And then, okay, here we have some method, void method, throws, file out, okay, starting from here and ending here. Then we have the main method, starting, ending. This is the try block. This is the catch block of this try, and then this statement is independent. It is always better if you are going to read and understand some program, it is always better to have a look over the whole program first, so that you will understand what is the structure. What is the structure of that program? So now we can go on. When we will run this program, it will search for the main method. This is the main method. And then you will go inside this main method and try to execute all the statements one by one. So we have the try block first. And in that try block, we are calling this method. This is a function. This is the name of the function. So we are calling it. So, okay, we will come out of this one and we will search in this class. We are in the same class. We will search this method because there is no any object used here. So we will stay in the same class and we will search for this method. So here we will search for this method. So this is the member function which is available. So this is the member function which is available. So this is the method, return type is void. This method is not returning anything. I'm not going to explain it, you know that. I will go directly to the main things. So method, and here we have something written. Here we are using the keyword throws, not throw. We are talking about something, throw. We don't have any S at the end, but here we have the keyword throws, S at the end. And then we are writing the name of some exception class, that is file not found. If you have a doubt on some method, if you have a doubt on some method, that method can throw some exception. I'm using the word can. Can is not a compulsory or must condition. It can be, it cannot. So if you have a doubt being a programmer on some method, that method somewhere in it can throw some exception, then it is always better to write something as an alert in your program. So this is now an alert. So how you can write then? After the name of that method, after the parenthesis, you can write the throws and the name of that exception. And what is the meaning of this one? This will not throw any exception, okay? This will not throw any exception, surely. But this is just an alarm or alert that this method can throw this exception. What is that exception? File not found exception. And if this method can throw, then you can do something to handle that exception within that method. Within that method, you can. So this is just an alert. It will not affect your program. You can even remove that. But there are some rules for removal, etc., etc. We will see that later on. This is just an alert, okay? So don't be worried. So now method, this is the starting and this is the ending. And first here, we are opening in a file by giving it a complete path which is available. For example, here, file reader. This is a class existing in Java to handle files. So this is a class, not your own class. Already defined class, already available class in Java. This is what is his name? File reader. So we are creating an object of that class. So here we are just, this is the name of an object, nothing else, like obj. So file reader file is equal to new. And this is the way how we can create an object of a class. So then new, then again the name of the class. And within the parentheses, you are passing some argument, which is a string. This is basically a string because you are passing within the double quotes. But this string is the path of this file abc.txt. If you have that file similarly, you can have also a file in your computer which you want to open it here using this program. Then you have to give the path of that your file here. If that file is available on the desktop, then maybe C is the drive, and then users, and then your name, and then desktop or whatever the path of that file is, you have to copy that path. So this is the path where your program can find that abc.txt file, nothing else. And if your file is not placed somewhere far from this program, if your file is placed alongside your program, then you don't have to give this complete path. You can only write the name of that file, abc.txt. Anyhow, this is not the major thing here to give you the understanding about. We are in the exception message. So what here? If that file is available in your program, in your computer, then nothing will happen. That file will be opened and the reference of that file will be stored here in this object file. And the reference of, like, for example, then this object will be created. This object of that class file reader will be created. And now with this object, you can use many methods which are available in that class file reader. You can use them. You can access them by using that object. And here we are doing, we have another class. In Java, there is another class called buffered reader. There is another class called buffered reader. We are now creating an object for that class. So buffered reader, this is the name of the object, nothing else. You can write any name here, obj is equal to new buffered reader, and then within the parentheses, you are passing this object into it. You can pass object of one class as a parameter into another class. We have seen these examples already. So we are passing this object into it, into the constructor of this class, buffered reader. And what this will do, it will take this object as a parameter into it, and then it will read the whole file, and it will copy that text into this object file input. Whatever you have the text available in that file, that text will be copied and the reference will be stored here in that object. Buffered reader is a file with now your text is in the RAM. Buffered is normally is a word for your RAM. When you run your program, then your program will read that file and it will keep the text of your file in that object. So now what? Within these, and here after that, we are throwing what? We throw, this is the keyword which we are talking about. Throw new file not found exception. Now, either your file is existing in your computer, you are opening that file and reading that file in the second statement. But this statement now here will throw exception, explicitly. So we are throwing exception here manually. So the throw new file not found. So what exception we are throwing? File not found exception. And you have the parenthesis here, empty parenthesis, semicolon. So that exception will be thrown without any message. We are not passing any message into it within the double quotes. So now message is empty. Whatever the default message is, that will be displayed. Whatever the default message is for this exception class, file not found, that message will be displayed. You are not modifying any message here because you are not passing any parameter into it. Anyhow, so here the exception will be thrown. Due to this, when you are going to use this throw keyword within any method, it is always better to use this throws. So that's why this was here. Otherwise, it is not needed. File not found is a checked exception. You will see there are some rules. So that's why we are also writing this throws keyword. Anyhow, leave it. Then it will be complicated. I don't want to put you in complications. Just take the simple concepts. So now the exception will be thrown here. If it is thrown, then I have to stop here at this point. I have to stop here. And I have to come out of the try block. I have to stop here and I have to come out of the try block. And then I will have to search for the catch block because exception is occurring here. So now I am going to stop. And this is the method. So I will come out of this method. Okay. And here the method is here and in the try block. So now this method, which is this whole one, this is basically causing exception, which means, and here we are calling that method. It means this call to this method is causing that exception. So exception is here basically. First exception is occurring at this line. Then the second thing is, here we are calling that method. So the exception is also here. So either I have to search some try block here. Here we don't have the try block. So then what? I have to go to that method call. You have to go to that method call. So that's why you will come here, and here that method that is causing exception. Okay. So now here you have the exception. So you will come out of this try block, and this is the try block. So you will come out of this try block and will search for the catch. And it is file not found exception. Yes, it is matched. Type is matching. And everything, whatever you have, will be copied here into this E. We don't have any message, but exception is thrown. And then you will come into this catch block and E dot print stack trace. This is also a way to print something on the screen if it is something related to exception. If you want, because in the beginning of this lecture, of this exception handling, I told you what is this print, what is this stack trace. I told you there are 3 steps in it. It contains exception message, it contains exception hierarchy, and then the termination. It is a slide in the beginning of this lecture. So you can write system.out.println and then E into it. That is one way. This is also a way. E.print stack trace. E is an object of this class. And you are calling what? E.print stack trace. This is an object. Through that object, you are calling some method which is available in this exception class, nothing else. And within that method, the system.out.println is there. That's why it will print something on the screen. So E.print stack trace. So here that stack trace will be, and this is how stack trace is displayed. First, it will give you the hierarchy of that exception. And java.io.file.not found. This is that hierarchy. This is that hierarchy. Java io.file.not found. And after that, if you are printing stack trace, that will print the line number, the relevant line numbers where exception is occurring. At testthrow.method. So this method is this one, the method testthrow.line number 12. So this is the line 12 where first time the exception is occurring. And then testthrow main testthrow line number 20. So this line we are talking about where we are calling a method. So this is what? This is the stack trace, okay? Which you have the line numbers. Normally, this stack trace is used by the JVM. JVM also gives you the output like that. But here, this is not abnormal execution of your program. This is quite normal. But we are using the print stack trace. That's why our output is a little bit in a different way. And then what? Okay, now it is ended. You will come out, and the next statement is what? System.out.println, rest of the code which you are seeing here. And then your program is executing quite normally here in this example. Just a minute. Want to see that if there is something important, then is there anything important? Let's see. Okay. Just keep one point in your mind, and maybe we will, if there is something wrong with that point, we will correct it in future, in upcoming slide. Future doesn't mean that it will come after a month. It means that after maybe 2 3 slides it will come. And that thing is that unchecked exceptions are those exceptions which we can handle at runtime. So that is normal. That is in our control. Checked exceptions are something which is not directly under our control. So that is the reason that we use this throws keyword here. There are some other points, but just keep that point in your mind. If you are going to handle some checked exceptions, then for that, and if that exception is in some method like that, then you have to use that throws keyword, which is an alert. You have to, this is called declaration, okay? This is called declaration of the exception. So you have to declare that exception in the method signature. So where, what is this position called? This position is called method signature. I'm not inside, I'm not talking about inside the method, within the parentheses, within the brackets. No, I am talking about the position where you normally write method signatures. After the name of the method, you have the parentheses, and after the parentheses and before the curly bracket, that is the position. That is called method signature generally. By the way, the name of the method and the parameter position itself also the part of the method signature. But leave it. So this is, here you have to declare the checked exception if you are going to use a checked exception. This is the point. We will verify this point in upcoming slides. Now, another example, throwing user-defined exception. User-defined exception means custom exception. Custom exception means the exceptions that you will declare by yourself in your program. You will not use some existing exceptions. No, you will create your own exception class with your own messages, etc., etc. So that is called a exception defined by user defined exception. And we have a program here. Let's see this program. The class is the name of the, now we are writing a class, and the name of that class is user defined exception. This is our own name given to this class, and this is extended. And if you want to do that, you have to make a child class of the exception class. That is also a rule. We will see this topic in detail, but anyhow, we can leave it now. It is up to us, and we can continue when that topic will come at the end. At the end, we have this topic. That is custom exception, okay? And we will see that topic in detail. But anyhow, I am now going into this program just quickly. So we are writing a class, and if you want to create your own custom class, you have to extend that class from the exception class. So that's why it is now written here, extends exception. This exception is the parent of all the exception classes according to that diagram that you saw in the beginning. This exception is the parent class of all the exception classes, all the checked and unchecked exception classes. So if you are going to write your own exception class, then at least you have to extend that class with that parent class. So that's why user defined exception is the name of the your class, and we are extending with this parent class exception. So this is inheritance and starting, and then maybe ending here. The class is ending here. And then in that class, we have the constructor of this class, user defined exception, passing some str string type variable into it, and then in this constructor we are calling the super, we are writing super and then str, the same thing, passing into it. This super keyword will call the constructor with this argument. Constructor to what? Constructor of the parent class exception. Okay. So this super will call the constructor of this parent class, and it will copy that str into that constructor. And now whatever this str is, it is a string, it is a message. That message will be updated with the exception message of this page of this parent class. Whatever the default message existing here for the parent class, that message is now updated with this str. Okay, this statement is doing that thing. Then this constructor is ended, and then we have another class. The name of the class is test throw 3, starting and then ending. And then we have the main method, starting, ending. We have the try block, then we have the catch block, nothing else. When you will execute this program, it will search for the main method, main is here, and then it will execute one by one all the statements in it. So in the try block, okay, now this statement will, this is the first one, this will be executed, and it is written here, throw new user defined exception. What is this one? So this is the name of the exception class. Which class? This class that you have defined by yourself. This is the custom class that you have defined. So you are going to throw this exception, user defined exception, with this message. This is your user defined exception. So this is what you are calling construct. So this exception will be thrown with this message. This is the simple meaning. This is the simple meaning of this statement. What is the exact meaning? Exact meaning is that you are calling some constructor with this value as a parameter. So where is that constructor? User defined exception. This constructor is available here. And this string will be passed. This string will be passed here into this str, which is further copied into this using this super keyword, which is further copied into the constructor of that exception class, which is a parent class. So now you have this string as an exception message, and the name of your exception is now user defined exception, according to this statement. According to this statement, I have given you both the meaning. What is the simple meaning and what is the detailed actual meaning? So for you, it is easy to keep the simple meaning. So this statement is doing what? This statement is throwing this exception with this name and with this message. So when this statement is throwing message, so I will stop here and I will come out of this try block. And here you have the catch block. So exception is matched. Yes, exception is matched. The name of the exception, type of the exception is matching here. Whatever the message, exception message is, that will be copied here into this UDE, which is an object. And then system.out.println caught the exception. That will be printed on the screen. And then system.out.println UDE.getMessage. Through this object, you are calling some method getMessage, which is available somewhere in the exception class. Here in the user defined class, it is not available. Then where it is available? In the exception class. And that will do what? It will just give, it will return the message of that exception class, because this by using this super keyword, we have updated that message into the exception class. So what is the message? UDE.getMessage. This message will be accessed from the exception class. So then, and that will that message as a string will come here, that will be printed by this command, and then you can see this is user defined exception. And this was the message, this is user defined exception. Moving on, because we have to do more, so I don't want to stop. Okay. Now, another topic, Java exception propagation. You have heard the name propaganda. It's the English word, propaganda, okay? It means spreading the false rumors, huh? Normally means. But actually, we have that word again, propagation. Propagation means spreading something, distributing something. So if you have the Java exception in your program, and there are many methods or there are many try blocks also there, and if exception occurs very much deep inside method calls. Here I want to say that if you have 3 or 4 methods calling itself again and again, one method, and then method 2 is inside the method 1, method 3 is inside the method 2, method 4 is inside the method 3, method 5 is inside the method 4, and in method 5, if you have the exception, and the try block is available maybe at method 1, not in other methods. And if exception is occurring at method 5, then you have to come out of the try block. And try block is available at method 1, not at method 5. Then what? You will go to the previous call. Previous call is method 4. So that exception message will be propagated to the previous call, method 4. Method 4 again don't have the try block. Try block is with the method 1. So then what? You have to go back again to the previous call, which is method 3. So from method 4, you will go back to method 3. From method 3, you will go back to method 2. From method 2, now you will go back to method 1, which has the try block, and then you will come out of that try block. So this is what you are doing. You have started your journey from method 5, and then that exception message propagated back to method 4, propagated back to method 3, propagated back to method 2, and method 1 finally, where the try block is available, and then you can go further things. So this topic, Java exception propagation, will give you the understanding of those nested calls. Will give you the understanding of those nested calls. So just read this sentence. This is the actual. An exception is first thrown from the top of the stack. So that call, you can call that call stack, okay? From method 5 to method 1, which I have just explained, you can call that is the call to the method. Or you can give it a new name, call stack. An exception is first thrown from the top of the stack, or you can say from method 5. And if it is not caught, that exception message which was thrown at method 5, that you will come back to method 4. If that exception is not caught by catch method, it keeps on dropping down the call stack. It will keep on dropping down to the previous call. It keeps on dropping down the call stack to the previous method call sequentially. Sequentially means with tartib. So you will go to method 3, and then there you have the catch block or try block. Which means, have you handled the exception there? No. Then come to the previous call, method 2. So and you will keep on doing that, you will keep on dropping down, doing that until you will caught the exception, or you will reach at the very bottom of the call stack, or your calls of different methods will be ended. This mechanism is called exception propagation. Let's have a look over this example. And here on the left hand side, in some method M, exception occurring in method M, but not handled in that method. Then what? It will be propagated back to N method, but not handled there. So then it will be propagated back to the P method. So in this example, you will have the 3 methods here. It's very much small font again. Or, huh? Allah, Allah. Okay. So now we have the class test exception propagation. This is the starting, this is the ending. And here we have the first method M, and this is that method. Then we have the method N, starting, ending. Then we have the method P. This is the starting. We have the try block in it, and then we have the catch block in this method P. And here this P is ending. And then we have the main method, and the program is ending. When you will run this program, it will first search the main method, and it will execute the statements one by one in the main method. And here we have test exception propagation. This is the name of the class. Which class? This one, test exception propagation 1. And then obj is the name of the object, is equal to new test exception propagation 1. Here, this is what we are creating, an object, nothing else. And through that object obj, we can access the information which is available in that class test exception. In this class, whatever available, we can access that through this object. And then what? obj.p, we are calling the p method through this object. P method is available in that class. Okay, you can access it. So p method, where is p method? This is the p method. So this method here we are calling, and here we are, okay, execute it. This is a starting bracket, and in that we have the try block. Okay, try block is starting, and here the try block is ending, and then we have the catch, which is ending here. And in this try, we are calling another method, which is N. So this is so this is method P, and this P method, inside it have the try block, and that try block we are calling N method in it. So this is the N method now. So we will go there and execute it. And that method is calling another method M. So we will go there and search for M method, which is available there. We will go there and we will execute it. And in it, we have a statement in data is equal to 50 divided by 0, which is generating or creating an exception, you can say. So here we have an exception divided by 0. Exception is occurring. So when the statement where the exception is occurring, I will stop there. And this exception is available in this M method. So I will stop there. I will stop there, and I will come back to the previous call of this method. Where this M method is called? Here in the N method. So I will come back to that N method. This is what I said here. And here we don't have the try block. So this is the method. So then what? Maybe if this is a method, this method will go back to the previous call if the call is available. If it is not, then the program will terminate abnormally because there is no try block there. We are going back to the previous calls just to search the try block, proper try block. So where this method is called n, so I will go back there and here it is. So the control will go there. And this n try block is available in that p method. You can go directly to those statements. Okay, this statement here, exception is occurring. This is the m method. So where this is called? Here. And where m is what? It is available in the n method. And where this n method is available? Go there. Here. And this n method is within the p method. So I am going to previous call. Okay, went to the previous call and went to the previous call, which is the p method actually. And this n. So now that exception which is generated here is now propagated back at this point. And this is now you have the try block. So now what come out of that try block? The same rule. Come out of that try block. Okay, come out and search for the catch. And here you have the catch. And here exception is the parent exception class, not the arithmetic. But exception we have is the arithmetic. Is it okay? No, my question is it okay? Why? Why is it okay? Because it is a parent class. It can take care of the child's classes, okay? Because it is a parent class, that's why it is not a child class. If you will put some child class of arithmetic here, then it is not okay. It is a parent class. So that exception message will be copied here into this E, which will, but before that, here we have the message. System.out.println exception handled? Yes, handled. It will be, this thing will be printed. We are not printing E, we are printing our own message, you can say. And then what? Here now you have the exception which was generated is now handled. And you have called this P where? Here. So you will come back here at this statement because here you called this P method. And after that system.out.println normal flow, that will be printed on the screen. Okay, now your program is ended and executed normally. And on the right hand side, we have again the similar program with the test exception 2 starting and ending here. And then we have the M method, N method, and the P method, and the main method. And in the main method, first we are creating an object of this test exception 2 propagation 2 class. And then obj.p, we are calling this P method. And within this method, we have the try block. We are calling N method first. So we will go there in the N. And we are calling M method in it. So we will go into that M method. And here we have throw new java.io exception. And this is the message we are passing into it. So we are throwing an exception. The name of that exception is input output exception. Input output exception is a checked exception. Is what type of exception it is? Checked. Checked exception. And when you have the checked exception, so okay, at this statement, exception will be thrown with this message. Okay, that is okay. But it will go to the previous call here. This is propagation. So Java exception propagation does not work for checked exceptions, okay? Until you declare them with the methods. So Java, what I am saying, I am saying that checked exceptions do not work with the concept of propagation in Java. This is the rule. Until you declare them here with methods as a declaration. For example, if you will do something like that, then checked exception will work. Otherwise, not. Okay, this is what I want to say. So here you have not declared anything, so that's why this will not work and you will see some compile time error. Okay. Java, Allah, 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 Allah. When it will be finished. Just a minute, I want to see on which slide I am. 32. Oof, 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 oof. By the way, for the previous classes, I have written self-studies here. The meaning of self-studies here, read it by yourself. Read it by yourself.
It's included in the exams.
Huh?
It's included in the exams.
Yes, it is included.
Yeah,
it is theoretical stuff, but leave it anyhow. Java throws keyword. I don't have this energy, but let's see what will happen. Java throws keyword. So now this is not throw, this is throws. This is what I told you in the previous slide. So this keyword is not used for throwing exception. If you want to throw an exception, this is not the keyword you will use. If you want to throw an exception, this is not the keyword that you will use. What is that keyword? Throw only. But this throws is a keyword which you normally use to create an alert during method declaration. So Java throws keyword used to declare an exception, after the name of the method and before the starting curly bracket. Java throws keyword is used to declare an exception, only declare. It will not throw an exception. And it is only used for an alert. And what that alert say? That alert will say that there may be an exception can occur in that method. Okay. There may be an exception can occur in that method. This is the only information this keyword will give in your source code. And syntax of Java throws is here written. For example, this is the name of the method and the parenthesis, and this is the return type of the method, for example. Then you can write, and this is the starting bracket and ending bracket of your method. And here you can write that this keyword. You can use the throws and then the name of that exception clause. You can write that. This is the syntactical example of that throws keyword. This is the syntactic guidance for this throws keyword. If I say write the syntax of Java throws, this is what I am asking to write, okay? And then normally in the examination, mostly students then ask, we have to write what here? So I am just demanding syntax. And which exception should be declared? What type of exception we should have to declare? This is called declaration, okay? What type of exception we can declare? We can declare checked exceptions only, it is just written. There is no need to declare unchecked exceptions. because those can be handled at runtime easily. So there is no need. Compiler will automatically understand. But for checked exceptions, you have to declare those checked exceptions here. And error is beyond our control. This is I explained in the beginning in the first slide, but it is just written here again, so you can read it. And what is the advantage of Java throws keyword? Advantage is that on the previous slide we have seen that this is the checked exception input, and we have the time compile error. Why these checked exceptions are not propagated? Because you have not provided the declaration here. So if you will provide that declaration through this throws keyword, then these checked exceptions will be handled and you will not see any compile time error here. So that is the advantage. That is the advantage. Mostly students do like that, but I know that they are sleeping. Yeah, huh? But I will not care because I don't have the time and I am seeing my destination ahead. I have to go there. So come if you want to come with me. Okay. Checked exceptions, because if you will, the advantage of this throws keyword is checked exceptions can be propagated then. This is called propagation here, which I explained here. Something happened in the P method, which is calling this N method, which is calling this M method. If exception occurs here, then call back, or propagation back. So that propagate when you propagated the calls back, so that is the advantage of this throws keyword for the checked exceptions. Now, time up, 10 minutes are remaining according to my actual rule. According to yes. How much? Ya Allah. So case one here, catch and handled using try catch block. So now on the left hand side, you have first example. And in that example, we are calling a method that is declaring an exception. So let's have a look on this. Import Java io.io exception. This is not needed to import, but anyhow, you can understand that here we are importing input output exception class, nothing else. Then we have the class test throws one starting bracket, and here we have the ending bracket, and here we have the M method, and we are declaring here throws IO exception. This IO exception is what? This is checked exception. This is checked exception. So this is the starting of this method M, ending. Okay, leave it. And then we have another method N. Then we have another method P, which is ending here. And then we have the main method, which is ending here. When you will run this program, it will search for the main method. And here in the first statement, you are creating an object for that class. What is that class? Test throw one. This class, test throw one. We are creating an object for that one, obj. If we have the object for that class, it means that we can access all the information of this class using this object. Obj.p, here we are calling a method p available in that test throw class. This one, we are calling it. When you call it, you will go into it, and we have the try block starting here, ending here, and then the catch block for it. And in that try block, you are calling some N method, which is this one. So I will go there to the N method. And here you have the throws IO exception. So this, the use of that. IO exception is checked exception. So if it is a checked, you must have to declare with the method. So that's why you are seeing it throws IO exception. And then starting of this n method, and here we are calling some m method before the end of this n method. So I will go to that m method here, and here this declaration is again input output and starting ending, and here we are throwing that exception, throw new IO exception with that message. So here this exception, input out exception, will be thrown with this message device error. And here the exception will be thrown. So, okay, stop it and come to the previous call where it was called previously here. And this is a method. So now the propagation will work for the checked exception also. For the checked exception also. Previously it was an error here. Previously it was an error here for input output because there was no declaration there. But now we have the declaration. So now, yeah, I know game over, but my game is also over. We are approaching. Anyhow, so we will come back to the previous call. N. To the previous call. Yes. You want to go, don't waste our time. You can go. I'm just using 2 or 3 minutes, not more than that, okay? So you can go. No anger or anything. Just don't disturb and go. Okay. Go to the previous call then. So this M method was called in N. I was here at M. Go to the previous call. Here it is the previous call. Go to the previous call. Here it is the previous call. Now it is the try block here. Come out of that try block. What is the type of exception? Input output exception. So now when you will come out of this try block, this is the catch block. And here it is the parent class. Parent class can accept all type of exceptions. So that's why this IO exception will be copied here into this E. And system.out.println exception 100 will be printed. And this is the statement which is causing actually the whole thing, the whole story. This is the statement which is causing this whole story. So you will come back to that statement. The control will come back. And what is the next statement? Normal flow. So normal flow will be printed. What is? This is only a message. Nothing else. Because we are not displaying that thing here. So that device error, that message is available in this E. But we are not printing the value of E anywhere. So that's why here, if you will replace it with E here, then this message will be displayed here. Okay? We are not using it here. We are just getting understanding how the throws keyword will work. Okay, we are not, for example, interested in how we want to print the value of E or not. No. Actual concept which we are trying to understand in this program is how this throws keyword will work. So this is the actual understanding. Okay, I will start with this one, inshallah, next. It is not possible. No. I have the 4 minutes, but that person disturbed our mood actually. I will start from 33, inshallah. What is that section?
165.